Hi everyone, and welcome to this webinar. So today we are going to be talking with Jeffrey Shi from Unity. If you don't know me, I am Matt Leonard. I am the product lead for Udacity School of AI. And today we're just going to be kind of having a nice little conversation about deep reinforcement learning. So how we are, kind of addressing deep reinforcement learning at Udacity, and then also what Unity is doing with deep reinforcement learning. So thanks for coming, Jeff.
Yeah, thank you. Again, really appreciate being here. As Matt mentioned, I'm the product manager for AI here at Unity. Prior to this, I was at Microsoft building intelligent cloud products, and prior to that, at Deloitte in their advanced analytics practice.
Awesome, great. So I guess we can start by talking about what is deep reinforcement learning.
Yeah, absolutely. And you hear a lot about it today, and you hear it all in the news. There's actually two parts to deep reinforcement learning. There's deep learning, which is a subset of machine learning that mimics how the brain works using neural networks. And then there's reinforcement learning, which is this kind of technique of like trial and error, using punishment and rewards until the machine learns to do something right. And if you think about what we do, if you're touching a hot stove over and over, you're eventually going to stop touching the stove. Now, when you combine into deep reinforcement learning, it's this new kind of field where you're applying neural networks with reinforcement learning, and it opens up an entirely new types of applications.
Right. So then, so I know in kind of like recent times, we've seen a lot of kind of amazing advancements. So AlphaGo, for one, was beat the world's like top Go players, which is like 5 years ago,
Yep.
people thought it could never happen. And there's also OpenAI 5 that is like playing Dota 2.
Yep.
So what do you think kind of led to all these like recent amazing achievements in the field?
No, absolutely. One thing to know that the research in artificial intelligence has been going back for many years. I would think that in the last 5-6 years, there's been advancements both in the algorithms and methods and a few famous papers, as well as advancements in the infrastructure and computing side. In terms of the algorithms, in my view, there were a couple of really important sort of milestones. The first was DQN, which is deep Q learning, produced by DeepMind. That really was the first paper that really talked about a machine learning system for reinforcement learning that could be scaled. The other one I like to always refer to is GAN, which is generative adversarial networks, when you pit two neural networks against each other. And this is really innovative in that it can actually allow machines to actually produce synthetic images close to what a human could do. You see these YouTube videos, they call them deep fakes. Those fake celebrity photos, you see the ones where Obama, it looks like it's Obama, but it's a different kind of script. Very innovative. And of course, tons of research and multi-agent behavior, curiosity, and a lot of different techniques. On the infrastructure and infrastructure and framework side, you see a lot of advancements in just how cheap GPUs have become, how cheap computing has become, which has led to this being able to take this sort of research, theoretical approach and put it into practicality. There's probably too many to list in today's conversation, but if you think about TPUs, TensorFlow, PyTorch, these new frameworks, these new cloud computing techniques allow this kind of explosion in the space.
So deep reinforcement learning is a really new field, and I hear from a lot of students that are curious about how it's actually being used in industry. And so I know that you're using it at Unity. So, but how are you using it in gaming, and how are other industries using it?
Yeah, no, absolutely. Of course, Unity, we're the largest game engine, game platform company. So we look at deep reinforcement learning as being able to bring these concepts back for our game developers. Good examples are if you're playing a game and you're playing against an opponent, using deep reinforcement learning, these opponents in the game that are not human controlled can be taught to play like humans, and that's a very interesting new kind of experience, not just for our game developers, but ultimately for gamers. So for Unity, we're pushing the boundaries of what kind of new experiences we can create using deep reinforcement learning in the gaming industry. Yeah. Outside of the gaming industry, what we're also starting to see is that Unity can be more than just a game engine. It can be a simulator to do all kinds of interesting training and model building for applications in autonomous vehicles and robotics, and augmented reality, and even in the retail experience where you want to have the shopping cart or checkout experience of the future. So for us at Unity, we look at ourselves as first and foremost a gaming company, but that we also have this like a huge opportunity to enable many more fields and many industries using Unity as a simulator to do these kind of computer vision, deep reinforcement learning tasks.
Right. So then, yeah, so you're using it at Unity, and so our deep reinforcement learning Nanodegree program, we built a lot of our projects using ML agents, which is a framework that you are all developing, right?
That's correct.
And so I guess I'm a little bit curious, like how did like ML agents and then your like Unity's involvement in AI and machine learning start? Like,
yeah, absolutely. So a few years ago, one of our lead researcher by the name Arthur Giuliani was working on his dissertation. And there's a few other folks in academia that were using Unity, very loose networker folks, trying to use Unity to kind of push the boundaries of deep reinforcement learning. So he joined the company, and he joined up with our head of machine learning AI, which is Danny Lang. He formerly used the head of ML at Uber. Yeah. Came a few years ago and started this open source project called ML Agents. At the very core, what it is creating the bridge between the machine learning world and the Unity world. So if you want to, for example, train new kinds of models, either for the games or to take those models and put in the real world, you need to be able to connect those two pieces together. So the project was born out of just a lot of from the academia kind of community, and we kind of now have gotten our open source community is one of the top AI projects on GitHub, getting a lot of traction. In the deep reinforcement learning Nanodegree course, it's being used to sort of teach the next generation of machine learning engineers and enthusiasts. So.
Yeah. So I wanted to ask you about a few of your favorite projects that were built with ML agents in Unity. So for example, Popo.
Yeah. So Popo is sort of our de facto team member. It's a virtual corgi that was completely trained using reinforcement learning. And so what we've kind of taken the project with Popo is just to illustrate either new kinds of benchmarks or new kind of research in the ML and sort of deep learning space. So for example, initially we just trained Popo to in our iPhone game just to kind of go and fetch a stick. Now we've gone to every time we add in new, different kind of methods or techniques in ML agents, the toolkit, we use Popo as a way to sort of demonstrate that. So for us, of course, it's very cute. We have a bunch of game designers on our team that are helping us build these environments for us to showcase. And so for us, Popo is a great way to show not just all this new stuff that's going on, but actually illustrate how any game developer, any Unity creator can actually do this themselves.
Yeah, nice. Does Popo have a headband? Or did it used to have a headband?
Yeah, actually, so it's sort of like these little Easter eggs that we put in the game. So it has a headband. Nice. In some of the newer ones, there's a tomahawk version of Popo if you get into certain levels. So there's actually, it's interesting. We sometimes have him with a headband, so we sometimes don't. Yeah. So we're still figuring out if he likes the headband or not.
I like the headband.
Okay, well we'll keep him in then. Actually, I had a question for you, Matt. For us at Unity, we have a perspective of deep reinforcement learning. I'm just curious from your perspective, where do you see deep reinforcement learning going?
Right. So one of the biggest things is deep reinforcement learning is actually really inefficient. So a lot of the things that we've talked about literally take hundreds of GPUs and weeks to train these agents, right? Which kind of puts this out of range for, I guess, most normal people working by themselves, and you need to be in a big organization that has the resources to run on 100 GPUs on Google Cloud or AWS, right? So I think that's one kind of future thing that people are going to be working on is trying to make it more efficient. And then another thing is that it's still pretty difficult. I think there was a nice blog post sometime last year, earlier this year, where it's you build this thing and you train it, but it only works 1 out of every 3 times, right? So deep reinforcement learning is still really difficult to do, and people aren't very consistent when they train their models and build them. And so I think there's a lot of work to be done there. We're just kind of like scratching the surface of a lot of the algorithms that we're using. And then also just being able to like have nice frameworks around deep reinforcement learning. So I know Facebook and Microsoft and Google have all like come out with their own sort of frameworks for building deep reinforcement learning models, agents, and environments. And so I think there's just going to be a lot more progress around that as far as building like frameworks and all that stuff to make all this easier for everybody, right? So now we actually asked a bunch of you all like to send in some questions for us. So now I'm going to kind of read them out, and then Jeff and I are going to be answering these questions. So the first one, this is for Jeff. So what skills do you actually need to start creating your own environments in Unity?
Yeah, no, absolutely. There's sort of two aspects to that. In machine learning, you don't really actually need a lot of like really rich, heavy graphics kind of like environments. Sometimes just spheres and boxes, are suffice. However, Unity is actually designed to be, anybody can actually spin it up and like create content. It's really, we kind of like to, let's say we're like the Tableau of like game creation. It's super fun, really easy. We have tons of learning, from Udacity as well, support forums online. So, if you're asking like kind of what skills you need, I think mostly just a willingness to learn, and kind of bootstrap. Right. Because Unity really is designed to make, content creation easy. We also have an asset store that has, thousands of different types of objects. If you want a tree, you want like, buildings, where you don't have to do a lot of the artistry and graphics stuff yourself. And lastly, there are a lot of like companies, especially in the AI side, like for example, the Allen Institute Thor project, that are actually creating huge benchmarks for environments that any researcher or anybody can pick up to do more, kind of research against as well.
Awesome. Yeah, so I know that Unity uses C#, right? So
That's correct.
Do you actually need to know C# to start building these things?
Yes and no. You don't. Especially for the machine learning side, again, if you're just really needing spheres, boxes, really simple like representations of the kind of environments you want to create. Of course, if you know C#, if you want to create really, really advanced Unity projects, having some knowledge of C# really does help. And if you can do some of the C# side, then of course it allows you to create much richer environments. So it's sort of a yes and no thing. Anyone without C# can actually use Unity, get started pretty quickly. But as you progress and want to do much more interesting things, working in all of C# definitely does help.
So this next question is, how can I secure at least an interview if I'm in the middle of a career change? So without having like real experience or a PhD degree, would getting a Nanodegree program certificate be enough for a new career in AI or ML? So for this program that we're talking about specifically, the Deep Reinforcement Learning program, most of the jobs in this field do require PhDs because they are research positions. So a lot of the work being done in Deep Reinforcement Learning is just research. I mean, there are a few applications, but for the most part, people are still trying to figure out how to use this, in the industry. So that being said, these jobs do require PhDs, but just like completing the Deep Reinforcement Learning program itself is going to teach you a whole bunch of new skills and really kind of increase your experience as a machine learning practitioner. From our other programs, those are training you to join fields that are, there's actually people working in them. You don't need PhDs. You do need some experience actually working in some industry, doing some sort of development jobs, in some ways. But even a lot of that experience that employers are looking to see is not necessarily working for Google or working for Apple. I mean, it's literally just a year or two of building your own projects on your own. That's equivalent to working at a company. So kind of the best advice and the advice I like to give to everybody, all of our students, is that after our Nanodegree programs, you just take those skills that you learn and you keep building projects just over and over again. So with deep reinforcement learning, just find different environments from ML agents or OpenAI Gem. OpenAI is releasing a lot of environments. Unity has tons of environments. Yeah, and just train agents in these environments, And when there's a new paper that you see that you like, try to implement that. So that's pretty much like the best way you're going to go about actually getting these interviews. If you just build a bunch of projects, put it up on GitHub, write blog posts about it, and just kind of keep working, keep building yourself, building your skills.
That's great advice, Matt.
Thanks. Yeah. So the next question is, this is for you. So what's the next step of reinforcement learning towards artificial general intelligence? So besides, architecture tweaks and hyperparameter optimization.
Yeah. So I think the way we think about Unity is we kind of think about how intelligence happens in nature and all the different systems and mechanisms that support that. So for example, we have to eat to survive. We have to not get eaten by tigers and dinosaurs. And of course we have to multiply to survive. So if we think about what does it mean to have intelligence in nature, it's really supported by this infrastructure. And that could be everything down to our cellular structure, to the environments we live in. And if we think about this, how would we apply this to artificial general intelligence, is really this infrastructure piece. And if you could recreate the infrastructure sort of in a virtual world, oh, and by the way, you can speed up the time scale and you apply some time to it, that's how intelligence happens. And this is why we're really excited at Unity. Because you can create these virtual environments, you can simulate them in Unity, and we have the ability to simulate years, if not hundreds of years of experience. And so for us, we think this is sort of the first step in how we can actually recreate general intelligence, mimicking how it sort of works in nature.
The next question is actually kind of related to this. So we're talking about like the advancement towards artificial general intelligence, which is like a lot of research, that like kind of top research in this. So like, what do you think are like our other top research topics within deep reinforcement learning?
Oh no, that's a great question. For me personally, I think the most fascinating area is in this whole area of transfer learning. And so what it really kind of means is that you're training a bunch of stuff in the virtual world, right? It could be in a game. You're taking, you're creating these models. They work well in the virtual world. But how do you bring that into the real world application? And they call these things, with like reality gaps and like simulation to real. And you see this in like applications like autonomous vehicles, the robotics, and robots of the future, and everything that's like where we can take machine learning and actually like apply it in the real world in this sense. So for me, the topic of transfer learning, which is still a very, very, very early phases, really is that next step of actually like changing the way we live our lives because of deep reinforcement learning.
Yeah, I remember. Kind of speaking of transfer learning, there's I think OpenAI released a bunch of like Sega games, right?
Yes.
And they're like trained Sonic to run through these levels, but like the challenge was an agent can learn one level, but it couldn't perform on the other levels. Right?
Exactly. And even to go kind of one step with that, in the gaming context, once you train the agent to beat the game, what can you do with that agent? It's really kind of stuck there. In some ways, games help drive the research, but to actually take something that you're training in the virtual world and put it into something that could be used is extremely difficult thing to solve. So yeah, it's really fascinating space.
So what I'm really excited about as far as research are a couple things. So the first is meta learning, so learning how to learn, right? And so there's this really interesting kind of field that people are trying to teach agents how to teach themselves how to do things. So I think that's really cool. And then the other one is multi-agent learning, multi-agent reinforcement learning. So this is like, again, OpenAI 5, where you have basically 5 agents that are working as a team. And I think this is really interesting because you can kind of like take various tasks and break it up into separate parts and then have multiple agents like working on these separate parts together. And I think it's a really interesting avenue of research. In my personal opinion, I think it's probably the better way to go than having like one agent try to do like a giant task as compared to a bunch of different agents. And you can kind of think about like the human brain works. We have all these different parts in our brains that are like all doing different things, roughly. Yeah. So it's not like a one-to-one comparison, but yeah, so I think that's like a really interesting way to go.
Yeah. Absolutely.
Cool. So then the last question we have, so I guess like this is one I can answer. So where do you start in deep reinforcement learning? So what's the one thing you should do? So where do you start? What's the one thing you should do? Just write code. Like honestly, just build reinforcement learning agents, train them. A good place to start is with OpenAI Gym. They have a bunch of like really nice kind of baseline environments. The one I really like, just to like start with, just to kind of like a baseline for any agent you're going to build, is called cart pole. So you just have a little cart, and it's like on a track moving left and right. There's a pole on it, and the whole point is to move the cart so that the pole stays upright. And so you can just build a simple reinforcement learning agent, a bunch of different methods, just try it out on this environment. And actually, Arthur Giuliani, who works here at Unity on the ML Agents project, he wrote a really good series of tutorials on reinforcement learning and deep reinforcement learning. You can find that on Medium, so that's a great place to just start learning about this. But the most important thing is to just build stuff, like write the code, train your agents, and actually build things. Okay. So do you have any like other advice for starting?
Definitely echo that, and of course just research. Just keep reading about what the latest advances are, figure out not just in the academia world, but actually like what are companies doing? How are companies applying these? How are supply chain using reinforcement learning to solve problems? And so I think having that with some practical hands-on is a very powerful combination.
So that's all the time we have today for our conversation. So thanks, Jeff, for joining me and joining us, and thank all of you for watching. And just really appreciate all your questions. It's really exciting to hear what you're interested in and what you're wanting to hear from us.
Yeah, thank you, Matt. I really appreciate being invited on to chat with you today, and really excited to see what the students come up with going forward.